So now I get to welcome my two colleagues, Kat Ashcraft and Weiwei Mo. I won't repeat all the information on the web about them. It's pretty detailed, but let me tell you a quick story about how we got started, which happened right here in this room. They might not even know this story. About 7 years ago, almost to the day, a professor from the University of Maine Law School, Dave Owen, gave a fascinating talk in this room about new ways of thinking about balancing trade-offs involving hydropower, fish populations, dam safety, and other recreation, lots of issues. And within a month after that talk, a group of faculty from across New England, 6 universities, began working on a major grant proposal to the National Science Foundation. We assembled a team of experts that included experts in hydrology, communication, fisheries, economics, tribal sovereignty, landscape architecture, political science, biogeochemistry, public policy, on and on. In fact, by the time we were done, I think we had more than 25 faculty and over 50 graduate students, and we were fortunate to get a big grant from NSF. Along the way, we learned a lot of valuable lessons about science teams, and some of you may recall that 2 weeks ago we had a talk about team science, which is itself a really important field, and many of the people that worked on this project were trailblazers. So even though Kat and Weiwei were relatively early in their careers, they played many important leadership roles on this project. Kat is an expert in political science, public policy, lots of work on water in North America and around the world, as you'll hear. She's an assistant professor in natural resources and the environment at the University of New Hampshire. One of the things I learned a lot about from her is this field of negotiation simulation that she'll be talking about. She's worked on justice issues, climate adaptation issues, dispute resolution. Weiwei Mo is also at UNH, an engineer working on sustainability, water systems infrastructure. She recently was awarded an NSF Career Award, which is pretty much the top honor you can get at that stage of your career. She is an associate professor at UNH. And the audience for this talk, I just looked at who registered across all of North America, as well as Europe, many levels of government, non-governmental organizations in the private sector. So you can see that this is an issue that matters to a lot of different people in a lot of different places. So the title of their talk is Rendezvous for Sustainability, Creating Space for Science-Based Collaborative Solutions. Welcome, Kat and Weiwei.
There we go. So Weiwei and I are delighted to be able to share some of our reflections and what we've learned about creating space for science-based collaborative solutions with all of you, and we look forward to a lively discussion after our presentation. As David mentioned, the work that we're presenting today emerged out of a 5-year research project we call the Future of Dams that was funded by the National Science Foundation and provided us with the opportunity to collaborate with researchers and stakeholders from 6 different institutions, academic institutions, as well as non-governmental organizations and different levels of government and others in New Hampshire, Rhode Island, and Maine. We want to recognize those contributions as well as the contributions of two PhD students at the time, now doctors, Natalia Lushenko-Diesner and Kui Hong Song. And some of the contributors to the team are here today. Let's see. So in David's introduction, he started to lay out some of the challenges of working on sustainability issues. And Weiwei and I want to start by talking about our motivation for this research. We'll then go into some of the specifics of what we did through our collaboration, talk about some of what we've learned, and then reflect on our experiences as a result of this. So in thinking about sustainability, too often science is still perceived as an objective fact-finding process that produces neutral truths to inform a rational policymaking process. But often that science doesn't get used, and it doesn't ask the right questions, it doesn't involve the right people, and we really want it to engage with the messiness of how decisions get made and how knowledge is produced, to focus on three challenges. So first, thinking about developing capacity for systems thinking by integrating across scales and jurisdictions, diverse actors and different kinds of sectors, thinking about physical, social, economic science. We want it to work on facilitating participation between the researchers, decision makers, and interest groups, and really facilitate interest-based negotiations for thinking about policy innovation and making sure that the knowledge that's produced gets used in implementation. The United States is a heavily dammed place. Most major rivers and lots of smaller rivers as well have at least one dam on them. And the dams involve complex trade-offs. So on one hand, they provide significance for cultural relationships to the river system. They provide valuable functions such as hydropower generation, water supply, and recreation, but they also disrupt systems and lead to negative impacts like impairing water quality and blocking the movement of aquatic species that live in those rivers, such as, for example, fish that move between the river systems and the ocean. So in the United States, lots of our dams are lots of our dams are aging. Many hydropower dams are nearing a relicensing process. And so there are lots of upcoming decisions about dams. Historically, typically, decisions about dams have focused on making a decision about one dam at a time. But increasingly, we understand that there are ways to better balance the trade-offs across issues by looking at, from a systems perspective, and by engaging diverse stakeholders in negotiations to try to build consensus about what they would like to see about the future of dams. So the work that we're presenting really emerged out of a conversation that Weiwei and I had. So David, thanks for sharing that earlier conversation that you had, and I'll just share that this specific part of the research also engaged out of a conversation. So never miss the opportunity to have an interesting conversation. But Weiwei and I were sitting down together and in true interdisciplinary collaboration, started to talk about what kinds of methods that we're interested in using and what those approaches might mean, and really got interested in collaborating. So from Weiwei, I've learned a lot about participatory system dynamics modeling, and which is an approach that engages stakeholders to work with researchers to develop and refine a model that can simulate the outcome for different variables over time. So in today's research, we'll be talking about specific variables like fish populations, hydropower generation, and cost, but it could be any number of variables. System dynamics modeling can either be really specific for individual systems that can then be used to support decision-making, or they can be simplified and abstracted versions can be used to promote systems thinking, sharing interests and knowledge. And that's really what Weiwei and I chose to focus on for this work. And integrating participatory system dynamics modeling with role-play simulations. Role-play simulations are frequently used to engage participants in an abstracted setting based on actual circumstances in a structured decision-making context. So they're used to identify key issues and for participants to share their priority interests for those issues. Often participants change the role so that they're given a role, they're assigned a role that's different from the role that they typically have. So for example, somebody who typically works for a state regulatory agency might be playing the role of an environmental non-governmental organization or an abutter to a dam impoundment. And the goal there is, number one, for thinking about the perspectives, for learning about the perspectives of other participants, but also to relax the constraints within which people typically are operating and free up the opportunity to think about innovations in problem solving so that they can start to brainstorm and explore ideas free from some of those constraints. So what we learned from our conversation was that participatory system dynamics modeling and role play simulation have complementary objectives. So they're often used for fostering innovations in policy. They're used for education and engagement, and used for research. And so we thought it would be a lot of fun and useful to work on combining these approaches. So the approach that we developed, and we're going to be talking mostly about our reflections on the final product and the final workshop that we ran with stakeholders, but we want to emphasize the process through which we developed that product, and the process as much as the product was the goal. But we wanted to develop a model and role play that through an iterative process that brought together stakeholder knowledge and expert knowledge. So we had a series of stages where we developed kind of a mock-up of what these products could look like. And in literature, people talk about that they shouldn't really be too good or too complete initially, so that the goal is really to foster conversations with researchers and other stakeholders about how to improve those products. And that's what we did over an iterative process that engaged the research team and students, as well as at an academic conference to engage other technical experts in the field, but then also through a series of 2 workshops that we ran in New Hampshire and Rhode Island with stakeholders. The first one focused on engaging stakeholders, getting to know one another, refining, improving the products, and then the second, where we had this role switching workshop focused on innovative problem solving. So the final workshop engaged participants with 4 different elements. So they're the system dynamics model, which Weiwei is going to talk about more in a moment. The participants actually engaged with that model through a web-based user interface, and they were able to simulate different kinds of options for setting a series of dams. And then there's a general setting that was provided through written general instructions that were provided to participants that gave them the structure of or the context of the decisions that they were engaged in. And then there were 7 participants and a facilitator, each of whom had confidential instructions about their own role. So what are the issues that are important to them? What are their priorities? And what can they push for in these negotiations? So the negotiation setting, these elements were developed through, again, the collaboration between stakeholders and experts. The workshop agenda for that second workshop, participants had time to get to know one another a little bit and to prepare. Much of the workshop was focused on the actual negotiations, and then there was time for debriefing, discussion, and reflections at the end of the workshop. So the negotiation setting the participants whose roles were defined and the decisions that were defined were all informed by a stakeholder assessment that was led by Natalia Lushanka-Diesner and myself, focused on thinking about what is common or typical of dam decisions and how can we think about creating a realistic but abstracted context for engaging stakeholders in those decisions. So the negotiation setting that we created is based on the Pearl River Basin. There's a main stem of the river and a tributary, the Mill Creek. The basin is a coastal basin with 5 dams that are located in it. So 3 dams on the main stem are hydropower generating dams that are owned by a hydropower operator. And then there are 2 dams, Dam A and Dam B, on the tributary of the Mill Creek that are owned by the town of Allen. Dam A has been issued a notice from a state regulatory agency that it poses potential public safety hazard. And so the impetus for the negotiations is that the town of Allen needs to come up with a strategy for what to do with Dam A. It has to do something to address that notice of public safety. And knowing that dam decisions are contentious, the town of Allen wants the decision process to be participatory. These other hydropower dams in the basin have upcoming decisions about for hydropower relicensing. There are lots of stakeholders who are interested in participating. So the state agency has convened a meeting of a working group to try to see if there's a way to do something different that might involve multiple dams within this basin. And the working group is excited to use a new system dynamics model that has been developed by a local university to inform their decision-making. There are 7 different stakeholders plus the facilitation team. The stakeholders represent different kinds of interests and then also different types of stakeholders. So we have, for example, historic preservation and hydropower generation, homeowners, we have ecological interests, as well as different levels of government. And the 3 decisions that the working group faces are, first of all, which dam should be addressed? So should it only be that one dam, Dam A, that has that notice of public safety, or should it be other dams in the basin? And for each of those dams, there's certain kinds of options that can be considered. Who's responsible for implementing any plan that gets decided upon? Is it going to be just led by experts, or is there going to be some kind of participatory committee that's going to work on implementing the plan? And then importantly, who's going to pay for this, right? So we can dream up lots of options, but who's going to actually pay for implementation?
So I'm going to give you an overview regarding how the system dynamics model was set up. This part of the work was led by my former PhD student, Cui Hong Song, who is now a postdoc at Princeton University. So at the very beginning, we first developed a model for a real river. And that model was developed in collaboration with Professor Joe Sidlewski at University of Maine, as well as his students, as well as Dr. Sam Roy, also at that time at University of Maine. After the model initial version of the model was developed, it was peer-reviewed and then published as journal publications. But then we modified the model into a kind of a hypothetical river basin. And that hypothetical model was later on used in the stakeholder workshops. So in that model, we included 4 different dam management options. One is, of course, dam removal. And then we also considered fishway installations. For fishways, we considered a couple different types of fishways. And I'll go a little bit into more detail about that later on. And also we considered about upgrading the non-powered dams into hydroelectric dams, and also repair of a dam, especially the Dam A, which has received a letter of notice about deficiency. So we have to consider the potential repair for that dam. And we particularly modeled 3 different types of attributes. One is fish population, and we considered 4 different types of fish species. One is alewife, one is American shad, one is Atlantic salmon, and one is sea lamprey. And the 4 fish species were selected based upon their economic value as well as their prevalence in the region. And then we also considered hydropower generation. And the 3rd attribute we modeled is economic cost. The model was run on a daily time step over 150 years time frame. And the model is entirely dynamic, so it can show over time how the fish population, hydropower generation changes. So here I want to share that although the model is dynamic, and also in the first version of our user interactive user interface, we included the dynamic results in our model. And it does show, for example, for fish population, it would oscillate over the different seasons because of the fish population changes and the movement between the ocean and the river. And later on, we found this kind of representation of the results was very hard for the stakeholders to make sense of. And also we found that there isn't really much use of the dynamic information in informing the stakeholder negotiation. So after some discussion about this issue, eventually we decided just to show the stabilized fish population as well as the overall hydropower generation, overall economic cost as the final results from the model. So I just wanted to highlight it because that shows one kind of iterative step in the model development after communicating with stakeholders and how we have adjusted the model over the time, which is informed by the stakeholder feedback. So now I'm just going to give you a high-level overview regarding the 3 components of the model. So for the fish model, it was developed based upon the activities as well as the survival of different fish age groups throughout their entire life cycle. So if for a typical watershed, if there's no dam blockage, then the fish would be able to access all the habitats across the watershed, and that would be the ideal condition, right? However, if there are dams, then the story would be entirely different. So usually during the spawning season, the females would migrate. If they're diagamous fish, they would migrate from the ocean to the freshwater rivers. And if there are dams, then the spawners will be trapped below the first dam on the river. And if the available habitat area is very limited in that segment of the river, then there will be huge competition among the spawners, and there wouldn't be a lot of survival of the eggs as well as later on the juvenile fish. If the dam has certain capacity for the fish to pass by, so for example, if the dam has a fishway installed, then some of the spawners would be able to move up beyond the dam and access the next habitat area. And similarly, then a part of those fish would be able to further move up if the second dam is also has certain capacity for the fish to pass. So then an even smaller amount of percent of the fish would be able to pass the second dam and access further habitat areas. So after that, the fish, the spawners will spawn, and then they will return to the ocean. And during that time, they might experience turbine queues. And then usually during around June time, the eggs will spawn, and then the juveniles will return to the ocean as well. And during that time, there would also be turbine fish queues when they migrate downstream to the ocean. So here are the 4 different types of fishways that were considered in our model. And so you can see for different types of fishways, they have different pass rates for different types of fish species. And those data were mainly collected from the literature. And some of the fishways have a higher performance for certain fish species, but some of them might have lower performance for certain of the fish species. So all of those were incorporated in the model. So then for hydropower generation, the second component of the model, we applied a kind of a typical hydropower estimation equation in our model, but that model is also dynamic. So we would be able to simulate the daily hydropower generation based upon the river flow. And so under different dam management decisions, the hydropower generation will also change. So for example, if a fishway is installed, then some of the water will be diverted to the fishway. So that will slightly reduce the amount of hydropower that can be generated. If a dam is removed, then the entire hydropower generation capacity will be lost. If a non-power dam is being upgraded, then that will add hydropower generation capacity to that dam. So all of those details were also included in the model. And also during the kind of the iterations of model improvement and communication with the stakeholders, we did adjust the hydropower model along the way. So one example is that when we had the first workshop with stakeholders, one of the hydropower operators came to us and expressed some of the kind of considerations regarding the hydropower number. And he felt, oh, the hydropower generation is a little bit high. And then we went back and did find, oh, there is a little kind of mistake in the model. And then we were able to adjust that number. And then the hydropower generation value became a lot more reasonable to the stakeholders. And then the last component is related to the cost of the dam management options. And for that, we obtained the data mainly from NOAA, and they had a database with around 70 different projects that have been conducted before. And we, through our connections with NOAA colleagues, we were able to have access to those data, and then we were able to delineate the cost based upon per vertical meter rise of the dam. So we were able to estimate the fishway installation and dam removal cost for each of the dams considered in our hypothetical model. And then in the end, all the modeling components were combined, and then they were converted into a user-friendly interface. And that work was conducted in collaboration with the UNH Data Discovery Center. As you can see here in the figure, I don't know if they're clear enough, but on the left, this is like the very first screen where the stakeholders can select what kind of management options they wanted to choose for each dam on the watershed. And then the second picture on the right here is showing under the selection of the stakeholders regarding the management for those 5 dams, then what will be the fish hydropower and cost outcomes based upon their selections. Kat, you're muted, I think.
Thank you, Weiwei. So we want to start talking about some of what we learned from the process and the workshops. So one of our goals was to engage a diverse group of participants. And so across the two final workshops, one in New Hampshire and one in Rhode Island, we did engage a range of different kinds of participants. A majority of the workshop participants found that the workshop was diverse, but still about a fifth of participants found that it wasn't. Particularly if you look at the workshop in Rhode Island, you can see that there's some stakeholders who are lacking. So we had the misfortune of running our workshops during the federal government shutdown. Also, our research team had fewer connections with the different stakeholders in Rhode Island. And I think it reinforces the lesson of really how important it is to spend time making connections with stakeholders and to work through connections with different groups so that the products can be useful. Some of the participants' reflections about engagement. Most participants found that their understanding of who's involved in dam issues increased, and also that their understanding of other stakeholders' perspectives increased. And I think this is really interesting, particularly because the stakeholders overwhelmingly engage, or the workshops overwhelmingly engage stakeholders who are participating actively in dam decisions on a regular basis. And so the fact that the workshops were able to increase their understanding, even when it starts out at a relatively high familiarity, I think is important. Some of the kinds of lessons that participants highlighted in quotes and survey responses focused on the importance of having spaces that engage diverse stakeholders to engage in brainstorming. So creating those opportunities to talk about options before you get to the point of decision making. And I think that was also one of the things that came out in the workshop discussions or the reflections after, is that the kind of approach that we're talking about is useful early on in a process where you can bring together stakeholders, they can get to know one another, they can learn more about possibilities, rather than close to when a decision about a specific dam needs to be made, or a system of dams. There were also a number of concerns that participants voiced about the lack of opportunities for bringing together diverse representatives. So comments that that's not currently the case, or comments about vocal minorities being able to dominate the existing forums, and an appreciation that this workshop did bring together diverse stakeholders, and that more of those opportunities are really needed for facilitating open communications and for thinking about trade-off modeling, for example, looking at those, how to balance those different interests. I want to highlight the quote about trade-off modeling in this participant's comment about how it's especially useful for bringing together less informed, or for mixing more and less informed participants. And I think one question that Weiwei and I had was about the extent to which participants of different knowledge levels from different backgrounds are able to participate in the approach. And so I thought that this was an important response.
So with regard to the decisions that have been actually reached during the negotiation workshops, so we have a total of 4 groups who have negotiated separately and reached consensus by themselves. And for each of the 4 groups, if we look at their decisions, so this table here is showing what kind of decisions each group have decided regarding each of the 5 dams on the hypothetical watershed. And we found for all of the groups, the decisions are about more than just dam A. So that kind of indicates there are some sort of system thinking when the stakeholders are engaged in decision, in negotiation, and they started to communicate with each other and gaining each other's perspectives, that kind of triggers the system thinking as well as potential policy innovation in the decision-making process. And then with regard to the usefulness of system dynamics model, so around 93% of the participants reported that they have increased understanding of the social, economic, and ecological factors after being engaged in the negotiation process, as well as interacting with the system dynamics model. And also, a majority of the participants found the system dynamics model to be very useful. So almost all of the participants said some system dynamics model is a bit or even more useful, and around half said the system dynamics model is very useful. And here are some quotes from the participants. One person said, the best thing I got out of this is how important it is to include all dams in the watershed in the process. I remember Cui Hong and I were talking after the workshops, and she shared that a lot of the participants, after they removed a certain dam or repaired a dam, they found that the fish population didn't change much or didn't change at all. And they were very surprised by the results. And they asked Cui Hong, because she was facilitating the workshop at that time, and they asked her why the fish population didn't change. And she told them that's because the downstream dams were still there. They're still blocking the fish passages. So of course, the fish population will not change much. So that kind of understanding, or that kind of insight that can be gained through this system dynamics model, I think it's very valuable to the stakeholders. So another quote is that easy access to model results are very helpful for trade-offs if trust can be gained. So again, this shows it's very important, especially in the early stage of model development. It's important to start the conversation with the stakeholders and really understanding what kind of parameters are important to the stakeholders, and try to build trust between the scientists as well as the stakeholders. And then when the model is fully developed, they would be more willing to use the model. And here are how our modeled results, as well, how the optimized results compare with our negotiated results, as well as how that compare with the status quo. So I apologize, this figure here is a little bit busy, and I'm gonna explain it just in a little bit more detail. So this first figure on the very left, it shows the negotiated results from the 4 groups. And there were 6 indicators that were considered, because those were modeled parameters. And on this radar chart, so if the polygon is bigger, or if the number on that radar chart is 1, that shows this indicator is performing the best. And if the number is 0, that means this indicator is performing the worst. So here, this first figure shows each color presents the negotiation results from one of the groups. For the second figure in the middle, this one shows the optimized decision based upon our model alone. So after we have the model, we also conducted a multi-objective optimization analysis using Python coding. And then out of all the optimized results, we set up thresholds for each of the 6 indicators. So then we identified 6 balanced Pareto optimal results. And here in the middle figure, it's showing the energy, fish, and the cost outcomes for the 6 balanced optimal results. I know this is a little bit odd, but yes, so those are balanced optimal results. And then for the figure on the very right-hand side, this is showing the results if we go with the status quo, meaning if we only repair dam A, which is the one that received a letter of deficiency, and we don't do anything to the remaining dams. So essentially it's an individual dam focused solution. So if we compare the 3, especially let's first look at how our negotiated results compare with the kind of scientifically optimized results. We can see that the negotiated results are very close to the scientifically optimized results. So that shows negotiation can actually achieve better or improved outcomes in terms of the indicators of consideration, and it can actually facilitate this kind of decision making in order to achieve better environmental as well as economic results. And then if we compare our negotiated outcomes with the status quo, which is only focusing on one individual dam, we can see that in terms of cost is actually the best in the status quo condition. Of course, because if you are only repairing dam A, then the investment is relatively minimal. But in terms of fish population, all the negotiated results have significant improvement in terms of fish population as compared with the status quo, with only minimal loss of hydropower generation capacity.
And then lastly, we wanted to talk about what we learned about the relevance for policy. So lots of participants, or majority of participants reported that their views about policy options had changed. Again, I just want to emphasize that many of the participants were already very knowledgeable about policy options. So I think it's a striking finding. Overwhelming majority that the approach modeled in the workshop should be used to make decisions about dams, and lots of participants saying that they're going to reference the work in their future, or the workshop in their future dam related work, showing that the approach is relevant for participants. I think that in thinking about the responses from participants about relevance for policy, I really found that there's an interest in creating these opportunities. So even though a participant here highlighted that the status quo is the easiest decision, there is interest in looking and creating these kinds of opportunities, so that if stakeholders are willing to change and engage with one another, that we can consider innovative approaches informed by knowledge that can meet diverse interests and foster new ways of thinking.
So in terms of implications, one thing we found that this kind of workshop combining model as well as role play simulation really provide opportunities for linking knowledge with action. Here, I just wanted to share my own experience. I'm trained as a kind of traditional engineer, and my background is actually water and wastewater treatment. It's only started from my PhD years, I got into the sustainability field. And for many years, I've never worked with stakeholders. And I never thought about the research I'm doing actually needs to be used. To me, it's normal that I just do some analysis and I publish it in a journal paper, as a journal paper, and then it's done. But this project revolutionize my view regarding how research is actually needs to be done and how the knowledge really need to be connected with real problems the stakeholders are facing. And also it's really important for us to be able to transfer this knowledge to inform the actual decision making. So for me, it's also a very educational process. And for me, I feel like I gained a lot of appreciation for working with stakeholders. And also it kind of became a new area for me to explore in my future research career. And I think this probably can also be generalized to a lot of other researchers who have been influenced by the Mitchell Center, as well as researchers who have who originally were trained as, for example, engineers or natural scientists, but they started to work with social scientists, and that kind of inspired new research areas and projects, and also the research became more likely to be used to inform actual decision making. So that's from the researcher side. But then for the stakeholders, this experience of participating in the workshop also helped them to one thing is to gain the systematic view of a problem. And then another thing is this negotiation process can help stakeholders really to have a way to apply the knowledge and gain experience in applying that kind of knowledge in negotiation and coming up with consensus and solutions.
I think just to hit on a couple other implications, one thing we thought about is that the interactive model was lots of fun to develop, but it was also very needy. So we were fortunate to have the resources provided by the National Science Foundation grant, as well as the contributions from all the research team members and the stakeholders who provided time and energy and knowledge into doing that. But lots of times you don't have those kind of resources. So thinking about what kinds of models might be appropriate for different sorts of circumstances where you might have more limited resources, I think is important. And also thinking about other kinds of needs. So not just the knowledge needs, but also, for example, to run a workshop like this, you have to have a reliable internet connection. People have to have a literacy level where they can engage with text materials. So thinking about some of the contexts within which this type of approach is and isn't useful. The model showed these quantified variables. The role play setting and confidential instructions also included information about non-quantifiable variables. And I think there's more work that can be done about thinking about how that gets included in decisions. And then also thinking about what types of participatory approaches are appropriate for different kinds of objectives. And so other members of the team included other types of participatory approaches, for example, participatory multi-criteria decision analysis, led by Dr. Sharon Klein, charrettes, so led by a colleague at Rhode Island School of Design, Emily Vogler. So thinking about, what is our goal here in terms of making a decision about a specific system or fostering systems thinking and innovations in how we think about policy design, and which of these approaches is more appropriate for different kinds of circumstances. I think looking towards the future, Weiwei and I are full of ideas, different kinds of applications. So running this workshop with different types of participants in different settings, but also for different contexts, such as climate adaptation, for example. Weiwei and I have had a lot of conversations about making sense of uncertainty, and I think that remains an area that's a challenge, both for researchers as well as for stakeholders, and a lot more work can be done, as well as identifying some of the drivers of change in decision-making processes. So what contributes to some of the results that we see? for example, fundamental questions related to decision science and communication, and then also questions about fostering social justice. So thinking about different ways to bring people together. So for example, looking at who's represented in these processes, how sources of systemic injustice are recognized, what the influence is on outcomes and equity, for example, and looking to see whether these approaches foster social justice or contribute to reinforcing power imbalances. So looking at what kind of design options are there. So thank you all for your attention, and we look forward to your questions and comments.
Okay. The first thing is, can everybody give a virtual sort of, this was really great, clap to let them know just how terrific this presentation was. That this presentation covered so much in such a short time, in such a clear fashion, that I think you may, as speakers, expect that a lot of people are going to want to follow you around. That we've learned so much from what you had to say. Just a few of the examples of sort of how you brought us on board and helped us think about things. Is you started off by really helping us understand that the U.S. is heavily dammed, and that it's not as if we're doing that just for fun, but there are very complex trade-offs. They're very clear issues that need to be addressed, and that many of these dams are getting older. And so as you helped us see, the question is now what? What's going to go on? And that one of the challenges that we all have and that we care so much about is we can do good science, but the science doesn't get used. So how do we create processes so that the science, the kind of science that you're demonstrating, gets used, where we link really detailed, important information with participatory systems and planning and modeling? And you've shown us how you really are thinking about those things. And a lot of people have some questions about how did you have this be successful? And near the end, you answered some of them. But let me just give a couple examples of some of the things that people would like to know more about, which is, let's suppose we're not thinking about dams and the future of dams, and we wanted to move into other topics. What suggestions might you have for us to think about how we learn from what you did here?
So I can start by saying, from the perspective of role play simulations, so these are often used in a range of different kinds of contexts. So the role play that we developed, for example, is now available as an off-the-shelf tool. There are similar role plays that are available that focus on specific kinds of negotiation questions or specific kinds of contexts that can be used. So I think that they are applicable in a range of different kinds of contexts. I think, again, partly it depends on, if you want to develop a participatory approach, it depends also on having an engaged group of stakeholders that cares about the topic and is willing to put the time into working with the team on developing and refining and reaching out to other stakeholders to engage with that.
Great. Thank you. Over and over again throughout your talk, it became very clear just how much knowledge you have acquired and how much knowledge that you have. As you think about universities now and you think about graduate students, how do we prepare them to become you? What should we be doing in graduate school so that people are able to bring these ideas together?
I can speak to about that because I'm from the engineering world, so I don't really usually work with stakeholders, and that's just how our education has been commonly. I think probably not only in the US, because I got my undergraduate degree from China, so it was the same way in China. So for me, I think having this kind of courses being offered to the students and probably requiring students to take some of the courses that's about how you engage stakeholders, how you communicate with stakeholders, how you manage a process of really co-developing knowledge together with stakeholders and making sure the tools you're developing is actually useful for the stakeholders and they would actually be willing to use after it has been developed. All of those are very important. And oftentimes the education we receive right now focus a lot on, for example, the engineering design, for example, the numerical values related to, for example, how big a building has to be, how for example, how the road has to be paved, or how the wastewater treatment plant has to be designed. But oftentimes there are a lot more considerations beyond those technical and engineering related things. There are things related to financial considerations. There are things related to power dynamics within and across different organizations. And too often those topics, they are not sufficiently being covered and discovered in our curriculum. So having that kind of courses, as well as maybe experiences, maybe beyond the courses for students to have, and maybe engaging students in research projects that are actually doing something that's engaging stakeholders, I feel like that would be very helpful for, at least for engineering students.
Very interesting. Yeah, go ahead.
I'll really quickly tack onto that. I mean, we said before we couldn't have done this project without the funding from the National Science Foundation. So I think having public investment in education for civic infrastructure is crucial. And so providing courses, providing research opportunities, providing engagement opportunities is just critical. So putting funding towards that, if we think that's important, we should fund it.
Linda, I'm taking notes because I'm learning so much myself.
Yeah.
Kat, I'll loop back to you about civic infrastructure later on. Anybody, Tony, do you have a question? Hang on, he's going to get a mic.
Yeah, thank you. I'm really interested in how these participants had access to these modeling and tools. Like, is this a common practices that's used in this type of engagement? And what did having access to these methods do for the participants, given the contentious nature of dam removal?
Yes, so I would say in real practice, it's not common. It's not common to have a model like what we have to be presented to all the parties that should be involved in a decision-making process. And then they would be able to kind of come together like that to explore the model and use that model to make decisions. Oftentimes when it's related to dam relicensing, if it's related to dam relicensing or dam removal projects, oftentimes the dam operators would hire consulting firms to develop relevant information in order for them to get relicensed. And usually that information is related to a single dam. So, this kind of information can be limited, right? If you only look at one dam and if you don't consider what kind of blockage are there downstream, then even if you, for example, make a perfect decision related to fish population, for example, about that dam, but if the downstream blockage is still there, it's not gonna help much. So the model we presented is really a kind of watershed scale model. And so then it can show you if you do one thing on one particular dam, it might not even help the fish population much if you have something downstream. So that kind of information, I think, is rare right now. Although we do have a lot of knowledge, a lot of information related to individual dams, but when it comes to a system level of knowledge or understanding, it's still relatively limited. That's my own observation.
And I think I'll just emphasize the interaction between the research team and stakeholders in developing the model, as well as the role play itself, the setting and decisions. I think what we wanted to avoid was the kind of adversarial use of science where different participants muster knowledge just in support of their particular positions, and really try to think about a different way of engaging around the knowledge to support brainstorming and problem solving. And so I think even outside of a role-playing kind of workshop like this, thinking about how people who are engaged in decision about dams or another issue are able to engage in an iterative process, for example, even with a consultant around that knowledge production is important.
Maybe I think we're at time. I've got
Yeah.
a bunch more things I'd like to ask about. And I think exactly where you are right now, Kat, even the point about, so who can do this work? You used the term earlier,
Yes.
the facilitation was done by a neutral third party. Plenty to think about there, right? Is anybody out there able to be completely neutral? Maybe not. Third parties seem like another important piece of the puzzle. But boy, have you guys given us not just a lot to think
Yes.
about, but also as great role models for where we need to go from here, not just about water and dams and fish and all those issues, but so many other sustainability issues. So I think at this point, just since we're at time, I want to thank Kat and Weiwei. Linda, great job. I'm going to manage to bring up my little clapping thing and do that. Anybody else that wants to?